Hey everybody, this is Mr. Beckstrom, and today I want to take a look at an example from section 4.2. This is a problem involving Rolle's theorem, and the question says determine whether Rolle's theorem applies to the function shown below on the given interval. If so, find the points that are guaranteed to exist by Rolle's theorem. So they give us a function here, f of x is equal to x times x minus 1 quantity squared on the interval from 0 to 1. And here's Rolle's theorem. It's also listed on page 251 in the book. It looks a little bit different, but it's basically saying this, that let f be a function that satisfies these three things. Number one, the function is continuous on the closed interval from a to b, so in this case from 0 to 1. Let f be differentiable on the open interval from a to b, that means from 0 to 1, not necessarily at the endpoints. And also let f of a equal to f of b. So let the function evaluated at 0 be equal to the function evaluated at 1. If all of these are true, then there is a number c in this interval, in the open interval a to b, such that the derivative evaluated at c is equal to 0. Basically, the slope of the tangent line is equal to 0, or we have a horizontal sloped tangent line. All right, so first of all, to make sure this thing is continuous and differentiable, let's go ahead and just kind of distribute this thing out here. So this is equal to x times, let's see, x minus 1 quantity squared. So we FOIL that out. That's going to be x squared minus 2x plus 1. And then we distribute that x, and you get x cubed minus 2x squared plus x. Now notice that this here is a polynomial, and one thing about polynomials is that on all real values x, they are both continuous and differentiable, therefore 1 and 2 are good. Now let's just check 3. We have to plug in 0 and 1 and make sure that the y values are the same. So if you put in 0, you're going to have 0 times something is going to be 0, so that thing's just 0, so that's good. If you plug in 1, you're going to get a 0 here, and 0 times 0 is 0. So either way, if you plug in 0 or if you plug in 1, your y value is 0, so it's going to be some function, I don't know what it does, between 0 and 1, but maybe it goes up and down like this, but it goes from 0 to 0. Now, since it's differentiable and continuous, that means that you can take your pencil and you can put it down and go all the way from 0 to 1, and you're going to end up at the same y value once you get there. And also, it's differentiable, which means that there's going to be no jagged turns, there's going to be no spikes, cuts, all those things. So it guarantees that there's some point somewhere on here where we're going to have a horizontal tangent line. Not necessarily there, but somewhere. So, if so, find the points where they're guaranteed to exist by Rolle's theorem. All right, so all of these things are true, right? All of these things are true. So now let's go ahead and find it. So in order to find it, what we're going to do is we are going to find the first derivative of this. So f prime of x is equal to what, 3x squared minus 4x plus 1. Right? We're going to set that equal to 0. So 3x squared minus 4x plus 1 is equal to 0. I just applied the power rule there. And now, let's see if we can factor this. 3x and x. And I think this is a minus 4, so that should be a minus 1 and a minus 1 there. So minus 1 and a minus 1, that'll give us our minus 4, so that looks good. So, and this is equal to 0, so that way x is equal to, what is that? That's going to be 1, and that's going to give us 1/3. All right. Well, what values are in the open interval? Remember, we're guaranteed a value in the open interval from A to B. So that's between 0 and 1. That doesn't include 0 or 1. So if it doesn't include 0 or 1, then this here is our value there. So 1/3. So this is our x value, and then our y value, which, well, just plug it in, right? So into the original equation, be 1/3 times 1/3 minus 1, which is 3/3. 3/3. That's a horrible. Parentheses squared. So I just put this back into the original equation. And what is this going to be? 1/3 times 1 minus 4 is -2. So -2/3 squared. And that is going to be equal to 1/3 times 4/9. Positive 4/9. Which is going to be equal to 4/27. All right, so your final point, or your C, is 1/3, and your point is what? 1/3, 4/27. That's it. If you have any questions, let me know, and I hope you have a great rest of your week. Thanks.